working with quadrantal angles. So what if we had a quadrantal angle and we wanted to try to apply these new definitions? Let's take, for example, theta equals 0 radians. Well, if I try to draw that in standard position, here's the initial side, and of course the terminal side is laying right on top of it. I don't rotate anywhere. I can still mark a point on the terminal side, but that's where the steps break down. I can't drop a perpendicular, which means I can't form that reference triangle, which means I don't have a reference angle, which means I can't use SOHCAHTOA. What in the world am I going to do? What I have to do then is simply rely on the definitions themselves. What does that mean? Well, remember, x and y stand for the coordinates of some point, any point on the terminal side. I'm thinking the easiest point that I could write down here would be 1, 0, over 1, and then up or down nothing. So that's the point I'm going to choose. That's my x and y. R stands for the distance from the origin to the terminal point. Well, obviously, if this is the point 1, 0, then the r here would be equal to 1. I can't really use SOHCAHTOA, but I can follow these definitions, and that's exactly what I'll do. Let's see, sine of 0, well, would be y over r. My y is 0, my r is 1. 0 divided by 1 is 0. Cosine of 0 radians, cosine is x over r. That's 1 over 1, which is 1. Tangent 0, y over x, 0 over 1, which is 0. I can get the other three by simply taking the reciprocal values. Cosecant is the reciprocal of sine. We had 0 over 1 for the sine function, so we'd have 1 over 0 now, r over y. Now you may remember that dividing by 0 is a mathematical impossibility. We can't do it. There is no such thing as 1 divided by 0. And so what we say here is that cosecant of 0 is undefined. That means it doesn't exist. You can't stick 0 radians into the cosecant function. There is no answer. Secant of 0 radians, we need to take the reciprocal of cosine. Well, that's pretty straightforward. 1 over 1 reciprocates to 1 over 1, which is still 1. And then cotangent, I used to have 0 over 1, now I have 1 over 0, which is again undefined. I would say these big three values are very important. The fact that sine 0 equals 0, cosine 0 equals 1, and tangent 0 equals 0. I would memorize those values, make some flashcards with sine 0 on one side, 0 on the other, etc., and test yourself. Let's try another one. How about theta equals pi over 2? Pi over 2 is, of course, 90 degrees. If I draw it in standard position, I end up here along the positive y-axis. I can mark a point on the terminal side, but I have no way to drop a perpendicular or to form a triangle. I do need to identify a point on the terminal side. I think the easiest point here would be 0, 1. So there's my x and y. R is the distance from the origin to the point on the terminal side. Clearly then r would be equal to 1. Notice that for any quadrantal angle I pick, I can always use zeros, ones, negative ones as my values. Okay, so let's write down our trig ratios. Sine of pi over 2, we refer to our definition. It's the y, which is 1, divided by the r, which is also 1. 1 over 1 makes 1. We're going to get a lot of the same answers we got before. Cosine is x, 0 over r, which is 1. 0 divided by 1 is 0. Tangent is y over x, so 1 over 0. There's an undefined. I'll abbreviate it UND. To get the other three, just think in terms of reciprocal values. The reciprocal of 1 is once again 1. 0 has no reciprocal. There is no 1 over 0, so this would be undefined. And for cotangent, let's see, tangent was undefined because it was 1 over 0, but if I reciprocate 1 over 0, I get 0 over 1, which is 0. So cotangent does have an answer. This time the two that were undefined were the secant ratio and the tangent ratio. I would say again, the big three values for pi over 2, worth learning and memorizing. The fact that sine pi over 2 is 1, cosine pi over 2 is 0, and tangent pi over 2 is undefined. So learn those. The quadrantals are tricky right now because they don't work with SOHCAHTOA. We will have one more definition that will help us with the quadrantals. That's still to come. Thanks for watching.